Alright guys, welcome back to the channel. Today we're going to be talking about in a series of videos about my newest rocket made called the Iris V2, a dual deployment rocket. So let's just not have any funny shenanigans and just dive into it. Alright guys, so let's dive into the dual deployment basics. So it won't be long. I'm just going to explain to you a bit about dual deployment before we get into it so everything makes sense to you guys. So let's just get into it. So what is dual deployment? So dual deployment in like very general and vague terms is when you have two parachutes that are ejected out of the rocket at two different times. So the first parachute, which is ideally the smallest parachute, is often called the drogue parachute, and this is ejected at apogee. So to revise on our definition, apogee is a like highest or like the highest height you have reached with your rocket. Okay, and then the rocket descends pretty quickly, but it's like a streamer, so it's not gonna descend too fast that it comes in ballistic. It's just gonna descend really quickly. And then there's a secondary ejection charge that fires at a certain altitude that you choose. So most times, as like here we can see, it says 500 to 700 feet. Yeah, so like that's a pretty good altitude to do it, and this really is useful because you don't have to walk a far distance, right? So we can see this whole sequence in a in this photo right here. So liftoff, the whole power flight, unpowered descent, the apogee and ejection. So this is when you eject, and then drogue deployment, and the main deployment, which is ideally at around 500 to 700 feet, and then you land. So why would I want to do dual deployment? So really the advantage is that the rocket descends really quickly, as I said before, and that's nice because for like cases like where you can see the rocket very visually and don't need GPS to find it or RF, what you would all you had to do is just look at the rocket and you won't really drift far, unlike your traditional motor eject deployment. Also, if you have a rocket that's like gonna go much higher in altitudes, the motor delay times can be insufficient. For example, if a motor has like a maximum delay of 14 seconds, but the rocket reaches apogee in 18 seconds, the delay charge will fire too early, potentially causing catastrophic failure, as shown in the image below. So that might not be exactly just because of a motor issue, but like the point is there that you don't want your motor to eject too early, or that will happen, and that would be very bad. Additionally, having electronics on board is very, very useful because when you get into this high performance stuff, as we're going to get into later on, we're going to see that when you go to the higher altitudes, as mentioned before, you really want to have electronics because that ensures that you have redundancy and you have more data. So, what, like, let's say a failure happens and it like deploy at 600 feet instead of 700. So, we can analyze that data of why that might have happened, right? So, and it's really good to get good at this at the lower impulse level, so then you don't have to be new to this at the higher level of impulse. So let's like dive into a very vague description of the configuration. So most times that we will use something called an eBay, not like the store that we use, like eBay meaning electronics bay. So as we can see, it's gonna be like in the middle of the rocket in this photo. And in this, we can see that the upper is your main chute and the lower is your drogue chute. So main is our big chute, drogue is our small chute. So this is at apogee, and this happens at altitude that you choose. So in this image, we can see what is inside the electronics bay, or what often people use. So you can see there's a PCB board, or as people call it, printed circuit board with your electronics, like your battery, and then your switch, and then it's held together by these two axle, these rods. So that's like the conventional way, but we're gonna dive into the one I used, which is a little more different. So before we do that, let's Alright guys, that's it for this video. We have covered the basics of dual deployment. In the next video, we'll be talking about the open rocket simulation of this phenomenal rocket. So let's not waste any time here, and I'm going to get to working on the next video, so please like and subscribe.